Hello again. This time I'm going to answer question 2 on part 2 of the study guide for Mid-Mod 2. Question 2 goes as follows. ABCD is a parallelogram with the vertices listed counterclockwise around the figure. Points M, N, O, P are the midpoints of sides AB, BC, CD, and DA, respectively. The segments MO and NP cut the parallelogram into 4 smaller parallelograms with the point W in the center of ABCD as the common vertex. Part A asks us to exhibit a sequence of similarity transformations that takes triangle AMW to triangle CDA. Be specific in describing the parameter of each transformation. For example, if describing a reflection, state the line of reflection. To get us started, I drew the triangle that we're moving, triangle AMW, in red. For the transformation I'm going to do, I'm going to draw the rest in blue. So, how can we start this problem out? Well, an easy way, in my opinion, to start this problem out is if we rotate. We can rotate. Well, how are we going to rotate? I'm going to rotate with center W. The reason I'm doing this is because I want this red triangle to end up on the second half of the parallelogram, basically on the other side of the line CA. If I rotate it around center W, I can rotate it by about 180 degrees. Well, where is that going to put our triangle? It's convenient that the parallelogram is split up into 4 different parallelograms, because if you can remember, way back when we covered rotations, a 180 degree rotation will take us 2 quadrants over on the coordinate plane. The logic is very similar in this parallelogram. We're going to move basically 2 quadrants over. What do I mean by that? Well, if we look at our first quadrant, WMAP, we're going to move once over to PDOW, and then another time over to OCNW. We're going to end up somewhere in this top left. Where am I going to end up exactly? Well, if we do everything right, our new triangle is going to end up here. Just like that. Again, because we're using center W and we're rotating 180 degrees. It's kind of similar. You could have also stated if you wanted to reflect the triangle over the line NP, your triangle would end up in a similar position. So my first step would be to rotate 180 degrees about W. That would be our first step. And I'm going to draw each sequence of the transformation in a different color, so hopefully it'll be easier for everyone to see. Next step, I'll draw in this nice purplish color. Step 2. Well, step 2, I need to move my triangle down a little bit because I need one of the vertexes to be on point D. Well, if I'm moving a triangle, what transformation describes that? Well, translation does. So we're going to translate and we're going to translate our entire triangle such that our point O is going to shift over to point D. So I'm going to say translate O onto D. And by definition, when we translate one point of the triangle, all the other points are also going to follow. So W is going to go down to P, And C is going to translate somewhere on O, or on O, I should say. After that, connect the 3 points, and that's the new location of your triangle. And we're just about there. We want this purple pink triangle to become triangle CDA. CDA is this very, very large triangle here. Well, how can I get that to work? Next step's going to be in green. Well, do we have any type of transformation that can enlarge a triangle? Well, yeah, definitely. We just learned about that. It's going to be a dilation. We're going to dilate triangle DOP. Now, how much am I going to dilate it by? Well, if you notice, I need to have it so that the purple ends up covering the distance from D to C and from D to A. Well, if you remember when we took our compasses and we measured out the distances, you figured out what the scale factor was. Well, the scale factor in this case is just going to be 2, because we have this original distance here, and we're just making it twice as big on that end. And the same thing here. We have this original distance there, and making it twice as big. So our new points are going to end up at C and A. And when we connect our triangle, it's going to look like what we want. So we're dilating DOP with a scale factor equal to 2. And we also need a center of dilation. Well, my center of dilation is point D, because all the points are moving relative to point D, and also the point D itself is not going to move either. So I'm going to say center of dilation is D. And that gets us the triangle that we wanted.